Chapter 5, Slow Earth Movements. In the last chapter, we have studied the interior of the Earth. Changes occur constantly at the Earth's surface. These changes are caused by internal movements as well as external processes. In this chapter, we shall try to understand the slow internal movements and their effects. The internal movements that affect the surface of the Earth mostly take place in the upper portion of the mantle. A tremendous amount of energy is given out by the radioactive elements in the mantle. This energy moves in the form of waves from one place to another. Due to the flow of energy, movements are generated in the interior of the Earth. Slow Earth movements. The movements in the interior of the Earth that are caused by the continuous and slow emission of energy are called slow Earth movements. These slow Earth movements affect vast areas. These movements take place in a horizontal or vertical direction. Try to understand the effect of these movements on hard and soft rocks from figure 5.1. These movements give rise to mountains and continents. The slow movements lead to the processes of folding and faulting. Effects of Earth's movements. Earthquakes, volcanic eruptions, forming of mountains and continents are the effects of Earth movements. A. Orogenic movements. The movements that give rise to mountains are called orogenic movements. The movements in the interior give rise to two types of mountains, fold mountains and block mountains. Fold mountains. As energy moves through the interior of the Earth, soft rocks are subjected to compression. As a result, wrinkles, folds are developed. This process is called folding. These folds appear like waves as shown in figure 5.1. If the pressure is intense, the folds are large and acute. This leads to raising up of rock layers and thus fold mountains are formed. See figure 5.2. The Aravalli, Himalayas, Alps, Rockies, Andes, etc. are examples of fold mountains. Block mountains. Sometimes the movements in the interior give rise to energy waves that move away from each other. Such conditions lead to the development of tension in the rock mass. As a result, rocks are fractured and they move past each other along the planes of fractures. These fracture lines are called faults. See figure 5.3. In hard rock layers, the compression caused by the converging energy waves can also lead to faulting. When a portion of the crust between two parallel faults is raised up, it appears as a block. Hence, it is called a block mountain. See figure 5.4. The tops of block mountains are generally flat. They do not have peaks. Their slopes are steep, for example, the Meghalaya Plateau in India and the Black Forest Mountain in Europe. Rift Valley. When the movement is in the opposite direction and divergent, the crust is subjected to tension. At times, the area between two adjoining faults subsides. Such areas of subsidence are called rift valleys. See figure 5.5. Both the slopes of rift valleys are quite steep. For example, the Great Rift Valley in Africa. Epeirogenic movements. The movements that give rise to the continents are called epeirogenic movements. Slow movements keep on taking place either towards the center of the Earth or away from it towards the crust. Due to such movements, an extensive portion of the crust is raised up or subsides. When a portion of the crust is raised above sea level, it leads to the formation of continents. Hence, such movements are called continent-building movements. Such movements may also give rise to formation of extensive plateaus.